In 1950, by the banks of Lake Edward in Central Africa, a mysterious bone was unearthed, carved with strange ancient patterns. It would come to be known as the Ishango bone. But its story began over 20,000 years ago, in a time before writing, before metal, before numbers had names. Someone began to count. What were they tracking? The moon's rhythm? The days between hunts? Or perhaps the first language of mathematics? Today, the Ishango bone rests quietly in a museum, but its mystery lives on. A simple tool, or the first whisper that humans were learning to speak in numbers? The journey of numbers continues, and it may have all begun with a few careful scratches.
Long after the first scratches of the Ishango bone faded into time, a new way of counting began to take form, not on bone but in clay. Nearly 10,000 years ago, in the fertile lands of Mesopotamia, early scribes and merchants shaped the first counters, small three-dimensional clay tokens. Each shape had meaning: a cone for a small measure of grain, a sphere for medium, a flat disc for a large one, the tetrahedron. The tetrahedron, a symbol of human effort, perhaps a day's labor. But memory needs more than objects, and so they pressed them into soft clay, ending behind impressions that would outlast lifetimes. These weren't just marks, they were records. The circular and triangular impressions told stories of grain, trade, and toil. Surrounding them, the official seals, the first signatures of scribes. From these humble signs, cuneiform was born. From scratches on bone to impressions in clay, the language of numbers was no longer whispered, it had begun to speak.
This is the oldest known clay tablet containing mathematical computations. It was created around 2700 BCE in the ancient land of Sumer, one of humanity's very first civilizations. Lies a multiplication table, etched in careful cuneiform strokes. A tool, perhaps, used by young scribes, practicing the ancient art of numbers. It's more than just math. It's a glimpse into how the earliest minds began to structure thought with symbols, patterns, and learning. This tablet, made in the Sumerian city of Shuruppak around 2600 BCE, holds a different kind of knowledge. It's a multiplication table too, but this one tells stories of space. 3 columns, 2 for distance, the third, area. Distances from 6 meters to over 3 kilometers, multiplied to measure land. This wasn't just calculation. This was measurement, governor, civilization itself. And it was all written in cuneiform. And in it, the earliest echoes of geometry were born. This humble clay tablet holds secrets older than Pythagoras himself. Plimpton 322, created around 1750 BCE in Samaria during the reign of Hammurabi the Great, contains rows of numbers, integer triples, that satisfy the Pythagorean theorem. Was it a teacher's tool? A trigonometry table? 1,000 years before the Greeks? Whatever its true purpose, this ancient relic reminds us that mathematical wisdom was being written in clay long before it was penned on parchment.
Nearly 4,000 years ago, a Babylonian scribe etched a square into a clay tablet. Its sides marked 30 units, and its diagonal, calculated with astonishing precision, shows they knew the square root of 2 to 6 decimal places. This tablet, YBC 7289, quietly proves that Babylonian scribes understood geometry and the power of root 2 over a millennium before Pythagoras walked the earth. These two unassuming tablets, YBC 7290 and YBC 11120, were more than scribbles. They were practice exercises made by student scribes between 1800 and 1600 BCE, learning to calculate the area of trapeziums and circles. Using pi approximately 3 and averaging bases and sides, these tablets show a civilization not only writing numbers, but reasoning with them.
In the land of the Nile, nearly 3,600 years ago, a young scribe named Ahmose dipped his reed pen in ink. What he wrote became one of the greatest mathematical documents of the ancient world, the Rind Mathematical Papyrus. This 2-meter scroll contains 84 problems on multiplication, division, geometry, and fractions, a textbook for scribes, carved in ink instead of clay. Among its treasures lies the 2/n table, a clever system for breaking down rational numbers into unit fractions, a core concept of Egyptian mathematics. Ahmose may be the earliest named contributor to math, whose work still survives. And though he wrote for fellow scribes, his ink carries knowledge that echoes through the ages. The scroll was later found in Luxor by Alexander Henry Rind, and now rests in the British Museum, its fragile pages still whispering secrets from the sands of time. In ancient Egypt, Mena was more than a scribe. He was the pharaoh's eye on the harvest. Around 1420 BCE, his tomb paintings in the Valley of the Kings show surveyors using knotted ropes to measure land. They weren't just marking fields, they were applying geometry to life, ensuring fairness, food, and taxes. The wall paintings in his tomb show the different measuring and calculating techniques used more than 3,000 years ago. For example, in the first row, you can see how long distances were measured using ropes with knots at regular intervals.